In this video, we're going to cover the area threshold method, the first option of our two approaches. We've ran through this tool once before when working on the hydro conditioning of our DEM. However, now the use is going to be different, so some things are going to vary. Before citing conservation practices using the ACPF, the user first needs to define their perennial stream network. So once you have your hydro-conditioned DEM and the associated terrain derivatives, you can start this three-step process of developing your perennial network. First, you delineate a flow network. Second, you'll go in and manually identify which segments are perennial or at least of interest. And then third, you define that perennial stream network using the results of step 2. Step 1 can be done using two different methods, the area threshold method and Pucher-Douglas. Area threshold is an easily understood method where the user gets to specify a certain threshold, which makes it repeatable as well, meaning that no matter what watershed you use it in, you can always specify the same threshold if you wish. While Pucher-Douglas is a much more objective and scientifically based method, and the result is going to vary based on landscape characteristics. Briefly, I'd like to make it clear what we mean by perennial stream network and also why we emphasize the importance of this. So to begin, a perennial stream network is one which flows continuously. You can see in the first hydrograph all throughout the water year, there is a base flow. There's a continual flow within that channel. In an intermittent or seasonal stream, flow is only going to occur at certain times of the year when it receives water from, say, springs or from other surface source, such as during like snow melt or something like that. You can see in the middle hydrograph, for the beginning of the water year, there is no flow, the base flow is 0, but then between January and June, there is some flow that's likely due to snowmelt in that case. And then finally, you can have an ephemeral stream, and this is the one that only flows in a direct response to precipitation, and whose channel is at all times above the water table, which we can see there in the last hydrograph, where there's just very sporadic flow occurring, most likely due to an intense rainstorm. However, for the purpose of the ACPF, we mostly want to be designating our stream network where we are going to be applying conservation practices down the road. For example, one of our last tools is a riparian assessment. So, if you are going to be interested in applying riparian buffers or other riparian practices to smaller, potentially intermittent streams, you may want to include certain streams. However, for the most part, people are generally only concerned with perennial, that is, continuously flowing streams. That is why we make this distinction here. Alright, so we're back in our map document. You can see I have my terrain derivatives that I got after my hydro conditioning process. So I have my new DEM, which is now the original DEM I'll use from here on out. And you can see I still have this old area flow network output that I got when I was using a 5-acre threshold. If we go to our results and look at the last thing I ran, we can see in the messages here, my threshold was 5 acres. Now when we go to the toolbox, we come down to the same tool, flow network definition, area threshold, and we open that up. And we've got the same 3 to 4 inputs of the flow accumulation roster, flow direction roster, the user specified area threshold in acres, and then the optional watershed boundary. If you include this watershed boundary, the output segments have to be centered within this existing boundary. And you should really only do this if you're sure the boundary will not change or will only change slightly. I am not going to include it this time around because I want to see where the flow networks get placed based on the landscape. So we're going to put in our first input, the flow accumulation roster. Come over here, grab and drop. And now for the area threshold in acres, I'm going to up it compared to the last time I ran. This time I'm going to choose 15 acres. This is a subjective choice. You can do whatever you feel is fit for your watershed. The flow direction roster was automatically added, and then our output flow network is right here, already added. We get this warning that it already exists, but we know that we had run it previously, and that's okay. So we'll let it run. The area threshold value can vary greatly depending on what you're looking for. You can choose a small value, say of 5 acres, if you're looking to delineate channels that are above your perennial network. But if you're looking for more of the main channel, you would want to put in a higher value, say of 15 to even 25 or larger acres. This is up to the user depending on what their end goal is. I recommend that if you're unsure, you run this a few times and sort out what you would like to be identifying, and then make your choice from there. Alright, so the tool just finished running. We have our output, and we can see this new network is less extensive. So let's take a closer look at some of the areas. We'll go to the headwaters and see how far up our network extended. And we get an idea from our hillshade if this threshold that we chose was significant or not. In my hillshade, I do see some fairly incised channels that the flow network did not place some in. If we zoom in closer here, we can see these defined channels here. Without imagery, it's hard to tell if they're part of the perennial network or not. However, because no flow network was placed there by the area threshold network tool, I may want to rerun my tool with a lower threshold, say 10 acres or something. But if you found this to be significant enough and extensive enough, this output would work. I generally do choose a lower threshold value just to make sure it does extend far enough into my perennial network. And the reason you want to make sure it does extend beyond the perennial network is because when we move to the second step of that 3-step editing process, we're going to need to code our perennial streams. So to give a little preview into that second step of this 3-step process, we'll take a look at the attribute table, and we can see that we have this field called stream type, which right now is populated with all zeros. This will be the field that we are going to edit based on whether a stream segment is perennial or ephemeral or intermittent. So this is why it matters if our network extends far enough up beyond the perennial stream, because if it doesn't, then that segment just simply won't exist for us to populate with a 1 or whatever we choose to designate a perennial stream network. So then when we go to develop our stream reach, it won't be complete. Alrighty, so here's a brief recap of the tool that we just ran, the area threshold flow network definition. Next up, you can either move on to the Puker-Douglas tool or go on to populating stream type field, which is the next necessary step in developing your stream reach.